Okay, so the idea is going to be, like I already talked about in a previous section, what your elementary functions look like. Now what we do is we get into what we call transformations, okay? So one of the things is you want to know how the math works on this. So we're going to start on this problem. We have negative absolute value x. We're going to graph this without a graphing calculator. So the first thing that you want to do on this is you want to go ahead and you want to graph this, okay? So we're going to do the absolute value right here. So let's fill this out then. The absolute value of negative 2 is 2. Absolute value of negative 1 is 1. Absolute value of 0 is 0, and so forth like that. So that's going to be what we call the elementary function. So we're going to go ahead and plot that. So go ahead and plot those points. So we have negative 2, 2, negative 1, 1, 0, 0, 0. Let me get that fixed before this thing runs out of gas here. Okay, so that should be the elementary function on this then. Together, now it's coming back up. Okay, so we've got that. Now everything's messing up with this thing for some reason. I may have the wrong thing. No, I think I'm okay. Okay, I think I'm okay. Let me close this OneNote because something's messing up here. Okay, let me see if everything will work now. Okay, so we got our 3 dots here, and what you want to do is just kind of use a dashed line, connect the dots like that, okay, and then just write on there, label that that's y equals square root of x, or not square root of x, absolute value of x, okay? Now what's going to happen to this negative? That negative is going to multiply, and this is worth writing so that you know how this works, it's going to multiply all of the y values by negative 1. Okay, it's better to know it that way than it just reflects, okay, because you want to know the y part on this, so it's going to multiply by negative 1. So I'm doing this in my head. I'm just 2 times negative 1 is negative 2. That's negative 1. That's still 0. That's negative 1. And that's negative 2 like that. So those would be your next group of points. So now if we plot these points, we would have negative 2, negative 2. So you want to plot that. You would have negative 1, negative 1. So you plot that. You'd have 0, 0, and then 1, 1, and then 2, negative 2 like that. So that would be how your function goes, is like that. Now you want to do it like that. You want to get everything accurate. But yeah, that does reflect, because that's what the negative in front of the function does, is it makes all the y's go to opposites. Okay? Now we're going to do the domain of the graph I have in green. That's going to be all real numbers. So I'm just going to write that as negative infinity to infinity. Now, what would be the range of the graph in green? It's going all the way down, right? And then where does it end? 0. Ends at 0. So the way you would write that in interval notation is you would say this. You would say negative infinity to 0, and then you'd have a bracket there because that 0 is an included point on there. So that's a start for, we're going to do just kind of a few examples of each type of transformation. And we're going to build from the basics and get more and more advanced as we go through this, okay? Okay, let's go to the next thing here. So now what we're going to do is we have y equals x squared. So we're going to graph 2 things. We're going to go ahead and graph this first. And you can do this in your head. You're just squaring. So negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay, that's a parabola. So we're going to go ahead and graph those points and label the function. So that we've got negative 2, 4, negative 1, 1, 0, 0, 1, 1, and then 1, 4 like that. So that's what we call the elementary function. So we want to start with that and then just label that as y equals x squared. Okay? Now what's going to happen on the next row? Same thing that happened in the last row. Okay, you're really multiplying everything by -1. All the y's change, so that's going to be -4, -1. That's still 0. That's -1. That's -4. Okay. Now, if I go through and plot these points, okay, it looks like what I have is I have -2, -4. So you want to get that plotted. You have -1, -1. So you want to plot that. 0, 0, 1, 1, and then 2, -4 like that. So that's what your final product looks like, is like that. Okay, so that's the graph of y equals -x squared. Everybody see how that works? Okay, the negative in front of a function makes all the y values change. That's why it reflects it. Everything moves across the x-axis. The domain on this is everything. Okay, you can square any number. The range on this is exactly the same as it was in example 1. You're going from -infinity up to 0. Okay, so I'm doing the domain and range of the final product like that. So that would be the answer. Okay, everybody solid with that? Okay, we're going to build from simple to more complex as we go through. I'm going to do one more example of this, and we call this a vertical reflection. Okay, so with this one, now what we're going to do on this one is what kind of number do I have to use for x since it's under a radical? Positive numbers and 0. You can do the square root of 0. You can't have any negatives. So I went ahead and just used 0, 1, and if we use 4, that's good enough. Just use numbers that you know have square roots. So what I'm going to do is we're going to do the square root of 0. You can do this in your head. The square root of 0 is 0. Don't need to worry about that. It's just decimals. Okay, and whoops, hold on, square root of 1 is 1, so we definitely need to do that. Okay, so square root of 1 would be 1. We don't want to worry about those two. And then square root of 4 would be 2. So you want to go ahead and just plot those 3 points, and that's good enough. So we have 0, 0, 1, 1, and then over 4 and up 2, use a dashed line to represent the elementary function. So that's y equals square root of x. Okay, like that. All right? All right, what happens to the next function? What happens to all the y's? They go to negative, right? Because you're multiplying by -1. So that's going to be 0, -1, -2. Now, if you plot those points, you still have 0, 0. You have 1, -1. And then finally, you have 4, -2 like that. So that's the reflection. Okay, so that's the first transformation that you want to be solid with, is what vertical translations are. Okay, tell me what the domain of the green graph is. It's 0, infinity, right? How about the range? -infinity to where? 0. Okay, that's the biggest y. So this one would go like this. We say bracket 0, infinity. It's got to be a bracket because square root of 0 is defined. Then we say -infinity to 0 with the bracket like that. Okay, so that's the idea. So the idea is if you had a function, and it wouldn't matter what it is, it could be x cubed, but if you put a negative there, it just reflects everything over the x-axis. That's the idea, okay? All right, next thing we're going to look at is a vertical translation. We're going to kind of look at the easiest ones first, and then kind of build from there. So the elementary function on this is just y equals x, which is a line, and that just means they're the same. If y and x are equal, then you just bring those down like that, and then that will give you a set of points for your elementary function. So you want to go ahead and plot those. So we go left 2, down 2, left 1, down 1, 0, 0, 1, 1, 2, 2, and then you want to plot all those and label those. Okay, so that is your elementary function y equals x. Okay, we call that the identity function. We talked about that, I guess, last week when we were going over 3, 4. That's called an identity function. Okay? Now, what's going to happen is that 4 is it's going to add 4 to all the y values. Okay, that's the arithmetic. So it's going to move everything up, but you want to understand why everything goes up. So what I do here is I just add 4 to these numbers. -2 plus 4 is going to be 2. Do it in your head. -1 plus 4 is 3. 0 plus 4 is 4, 1 plus 4 is 5, 2 plus 4 is 6, okay? So what you do now is you plot those points. So if you do that, you would have left 2, up 2, you would have left 1, up 3, and then so forth, okay? So all those points have the effect of just being moved up 4 units, so that would be how the graph of y equals x plus 4 looks like that, okay? So if you have a function, and you add 4 to it, what it does just moves everything up, okay, because the y values get bigger, okay? The domain would be all real numbers, and so would the range, okay, because you got a line that's going infinitely down, infinitely up, okay? It's defined everywhere, okay? All right, everybody okay with how I'm doing that? Okay, and we'll kind of keep going through and just do a few examples of each to kind of get the idea. And then eventually we're going to put this all together. Okay, so on this one, okay, what we have, y equals x squared minus 4. So the elementary function is this part. The transformation is the minus 4. Okay, so just square these numbers. You want to do this in your head. That's 4, 1, 0, 1, 4. I'm squaring the x values. You're working with a squaring function. This is the parabola, so you want to go ahead and plot your points. Okay, like that. And just get those things put together. And then label that as y equals x squared. Okay, like that. Okay, so you want to just know how to real quickly put that together. Okay, what's the minus 4 going to do? It's going to make all the y values get smaller. You're going to subtract 4. You're doing 4 minus 4. That's why everything goes down 4. And then 1 minus 4 is negative 3. 0 minus 4 is negative 4, and so forth. Okay, that would be negative 3, and then 4 minus 4 is 0. Okay, so that's the y part of why this thing gets moved down 4. It's better to know that than it is that it just goes down 4. So if you plot your points then, you'd have negative 2, 0 would be a point. Negative 1, negative 3 would be a point. 0, negative 4 would be a point, and so forth. So if you get those on here, that final graph, the transformed graph, just looks like that. Okay, so what's happened is that thing has been moved down 4. Okay? All right, what is the domain of my final graph? From where to where? Negative infinity to infinity. All real numbers. Okay, that's all real numbers. Okay, how about the range? What's the lowest value of y? Negative 4, and then what? Then forever. Okay, so the way you would do this is you would say this like this. You would say negative 4, comma, infinity. You get that from observing the graph and seeing how the y values go. Okay, so that's the idea. Okay, everybody okay? Okay, let's do one with an absolute value. I want to usually give 2 or 3 examples of each transformation. Okay, so this one is absolute value of x with a 3 added to it. So if you do your elementary function, just do the absolute value of those numbers. So that would be 2, 1, 0, 1, 2, doing the absolute value. Okay, plot them out. You want to know that your absolute value function just kind of looks like a V that goes through those basic points, and that's good enough. If you get like 5 points, that's satisfactory. And then label that as y equals absolute value of x. Okay. What is the 3 going to do to my y values? It's going to make them get bigger by 3. Okay, it adds 3. So you're just going 2 plus 3, and you don't have to write that down. I just want you to know what's going on. 1 plus 3 is 4. 0 plus 3 is 3. So that's what happens. All your y values get bigger, so that therefore the whole graph just moves up 3 units. Okay, so you could actually do this like this if you wanted to. You could just take every one of these dots and just go 1, 2, 3 up, and you'd be fine. This one, 1, 2, 3 up, and so forth. Okay, so that's the transformation. We call that a vertical transformation. So that's the graph of y equals 3 plus absolute value of x. Okay, all right. So what would be the domain of my graph? All real numbers. Okay, good. Anything, you can take an absolute value of anything. How about the range? Where to where? 3 to infinity. Good. Okay, the lowest y is 3, then it gets bigger from there. So that would be bracket 3, then that would be infinity like that. Okay? All right, so what I've shown you, those are the 2 easiest transformations. So what you want to know as a student is like if you encountered something like x to the 3rd. Okay, that's the one that does this. It kind of has this shape to it like this. If I put a negative there, what does it do? It reflects it. If I put a plus 3 there, what does it do? Moves it up 3. If I put a minus 3 there, what does it do? Takes it down 3. Okay, those are the simplest transformations for students to learn. Okay, now next thing we're going to do on the next page, this is where it's a little trickier, and it kind of goes like this, where it all depends on where you put the number. So when you put that number inside of the function, it starts moving it left and right. It all depends on where it is. Okay, so one thing is, like if you had x to the third plus 2, that would move you up 2 because that's outside of that function. But if you put it inside, it starts affecting the x values. So we're going to do this like this. First thing we're going to do on this row right here is we're just going to do the elementary function. We're going to cube this. Okay, and you can do all these in your head. I don't care if you do them in your head. Negative 2 to the third is going to be negative 8. Negative 1 to the third is going to be negative 1, and so forth. 0 to the third is 0. 1 to the third is 1. And then 2 to the third is 8 like that. So those are your points on that elementary function. I think this thing only goes down 6, so let's add a couple of notches there. Okay. So the first point would be left 2 down 8. Second point would be left 1 down 1. Then 0, 0. Then right 1 up 1. Then right 2 up 8 like that. Use a dashed line for your elementary function. Okay, so that's going to be y equals x to the third. Okay, so you want to know what x to the third looks like whenever you see it. You want to know what that function looks like. Okay, now what we're going to do on this is I'm going to crunch some of these out just to show you what happens on some of these. Okay, so I'm actually going to start here with 0. Okay, I'm going to start with x equals 0. I'm going to do this kind of like this. So if I plug in a 0 into this function, I would have I'd have 0 minus 2. Because I want to show you how this works. I'd have 0 minus 2 to the third power. That would be negative 2 to the third power, so that's negative 8. So I'm going to put that like that. Okay. Now I'm going to move on to the 1. X equals 1. So if I do that and plug it in, I'd have 1 minus 2 to the third. That's negative 1 to the third. So that's negative 1, okay? Then if I go on to x equals 2, then I've got 2 minus 2 to the third, so that's equal to 0. Now I want you to look at my table of values so you can see what happens. Okay, can you see how these things are just shifting? Like that negative 8, what did it do? It shifted over 2. That negative 1, it shifted over 2. So that's what would happen. Now if you did these points, that would end up being negative 27 and negative 64 if you did that. But I want you to see that everything gets shifted over 2. Okay, so if you have an x minus 2, you're going to shift that way. Okay, don't get that backwards. It's going to turn out that's an x plus 2. You're going to shift that way. And that's why. I mean, you have to crunch it out to really see the details of this. So this is basically what happens. You've got these are 4 of your points. So the way you would actually do this is like this. If you want to shift something to the right 2, what you do is you add 2 to x, but you don't change y. So I'm going to do the same thing on this. You'd have negative 1 plus 2, and then the y value stays the same. This is only affecting x values. Next one would be 0 plus 2, comma 0. And then the last one would be 1 plus 2, comma 1. So notice what you get is you get a point, let's see, on that I got a point like 0, 8. Okay, oops, that's wrong. That should be a negative 8, and that should be a negative 1. I messed that up. That's negative 2, negative 8, negative 1, because that follows those points. So this next one would be 1, negative 1, and that's like what I've got on my table. And this next one would be 2, 0. Okay, and then the last one here would be 3, 1, like that. So what's happening is you just want to know that in that case, everything gets shifted to the right 2. So what I'm going to have you do on your final graph is just take every point and just move it over to the right 2. Okay, like that. Just every point goes to the right 2. Okay, if you do that, then you've got a real good graph. Everything is totally accurate like that. So that would end up being the graph of y equals x minus 2 to the third. Okay? So again, it depends on where that is. It's inside of the cubing operation. That means it's changing x. Does that make sense? If it's outside of the cubing function, everything's up and down. It's affecting y. Okay? So let's do a couple of these to kind of get the idea. So that one's going to shift everything to the right 2. Let's see, the domain on this is everything, and so is the range. Okay, that graph doesn't have a start and a beginning and end. It goes on forever in both directions. Okay? All right, and then this next one, let's go through and let's do this now. So now we have the square root of x plus 4. Now see, this is inside of the radical. Since it's inside of the function, It's left, right. If it's outside of the function, like that, then what is it? It's up, down. That's real important to make sure you get that in your mind, okay? So we're going to do the square root of x. Okay, what kind of numbers do I need to use for x? I didn't put them on there, so what should I use? 0. What's another good one? What's something you know a square root of? 1. And then what else? 4. That's good enough. You could go to 9 if you wanted to. That's good enough, and I'm out of room on my graph. So you want to just use numbers that have square roots. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is going to be 3. So we want to go ahead and plot those points then. So we got 0, 0, 1, 1, and 4, 2. And that's good enough. You don't need to go all the way to 9 unless you want to. So that's going to be y equals square root of x. Okay? So what I'm going to do on this now with this one is kind of the same argument as the last one. What happens on this is everything's going to move a certain way. So like if I started with x equals 0, and if I did this, if I started with x equals 0, I would plug into this function. I'd have square root of 0 plus 4. That's the square root of 4. So that's equal to 2 like that. So you would have, if x is 0, you would end up having 2 like that. Okay? This one's going to be a little harder to, I think, to see on here. So you got that 0.02. And then what would happen is basically on this one, I mean, what do you think happens? The one I did before that, everything went to the right too. Well, what do you think happens on this? Goes to the left. Okay, so everything that's going to happen on this is everything is just going to go to the left 4. It's a little hard to see that unless you crunched out more and more values. So the way I want to have you do this is like this. These are the kind of the 3 key points right here. Those are the 3 key points that I've written down here. What you do on this is you're really taking away 4 from the x value. So you're doing 0 minus 4, comma 0, 1 minus 4, comma 1, and 4 minus 4, comma 2 like that. Again, what I want you to understand is x changes, but nothing happens to y. Okay, so what would end up happening then if you plotted these points is just everything gets moved over. So you would end up with negative 4, 0, you would end up with negative 3, 1, and you would end up with 0, 2. Okay, so that's what's going to happen on all these points is it would go like this. This point goes to negative 4, 0. This point right here goes to negative 3, 1. And then this point right here goes to 0, 2. So everything gets moved to the left 4 on that function. So if it's a plus, that goes to the left. If it's a minus, that goes to the right. Okay, once you memorize that, then it's easy to do the graph. You can just move things over. That's the idea. Okay? All right. Everybody okay with that? This one's a little more complicated to understand. I think you have to kind of number crunch a little bit. Once you catch on to it, you can just do your elementary function and move stuff left and right. That's the idea. Okay? All right? So I'll go to the next page. I'm going to do one more of those, and then we'll kind of start putting together more than one transformation here to kind of finish this up here. Okay, so let's do absolute value. So when you do the elementary function, you're just doing the absolute value of those numbers. You want to be able to do this elementary function super easy, super quick. Okay, so let's plot those. Okay, and then that's going to be our elementary function. So that's going to be y equals absolute value of x. Okay, now what happens on this now is this one is going to move everything to the right 3. Okay, like that. So all these points end up getting shifted to the right 3. So the way you would transform these points, and I'm going to transform the points like this because you'll do some of this on your homework. You just go negative 2 plus 3 and keep y alone. Okay, you go to this next point, that would just be negative 1 plus 3. Again, don't touch y. 0, 0, you add 3 to 0, leave y alone. Okay, same thing here. 1 plus 3, comma 1, and then 2 plus 3, comma 2, like that. One of the things you'll do on your homework some is just move points. You'll also do graphs, but you'll also do points, so you want to know how those things work out. So it looks like what you would have here then, if you go through and move all these points, you can go to your graph. If you just move them all over 3, this point is going to go 1, 2, 3 over like that. So that's going to end up just being the point 1, 2. That's where that point goes to. The second point, 1, 2, 3 over, that's going to be the point 2, 1. Whoops, I'm doing the wrong point. This one right here is going to end up being 2, 1. Okay, you move this point over to the right 3, that's going to be there. So that would be this point, that would be 3, 0, and so forth. Okay, then the rest of them you can move over and just sketch your graph. Mostly what you're going to do is, like on my math lab, you'll generally graph that elementary function, and then you move that over, okay, like that. So that's the idea. Okay, domain on this would be all real numbers. What's the range on this? Where to where? 0 to infinity. Good. Okay, so that's how that goes. All right? Okay, so before I go to the next thing, I want to just kind of check you on a couple of things here, because I want to kind of build this and put this together. Okay, let's say we have x squared. You know that's a parabola. You want to know that. What would happen if I put a minus there? What would happen to the parabola? Upside down, okay? What would happen if I did this? Plus 5. What happens to the parabola?
Goes up.
Up 5. Good. What happens if I do minus 5? Down 5, like that, okay? Now what if I do this? What if I go x minus 3 to the second? Then where's the parabola go? Right 3. Good. Okay, what if I have plus 3? Left 3. Okay? So it all depends on where the number is. Inside is moving left, right. Outside's moving up, down. That's what you want to get down. Okay? Okay, so now the next thing I'm going to do is the stretch and shrink. I want to make sure we get through stretch and shrink today and show you how this works, because this is kind of the last key transformation, and then we'll kind of be putting this together next week, putting it all together. Okay, so we're going to do 2x squared. I have a number in front of the function, so let's look at how that affects everything. Okay, we're going to go ahead and do the elementary function y equals x squared. So square all these numbers. You do that in your head, and then you want to plot those points. So we have negative 2, 4, negative 1, 1, 0, 0, 1, 1, and then 2, 4 like that. Okay, that's our elementary function y equals x squared. Okay, now see what this problem says is it says 2 times x squared. Okay, what it's doing, and this is a worthwhile note to write to yourself, is that 2, what it's doing is it's multiplying all of the y values by 2. That's what it's doing. It's doubling the y values. So that's what I'm going to do, and I'm going to do this in my head. 2 times 4 is 8. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8. So that's what that 2 does. It multiplies, okay? So now what's going to happen if you plot those points on this graph? We need to go up to 8. So you would now have a point negative 2, 8. So that would be way up there now. You would have a point negative 1, 2. You would still have the point 0, 0. And then you would have the point 1, 2. And then you'd have the point 2, 8 like that. So that's what your parabola looks like. What happened to the parabola?
Narrow.
It kind of narrowed, okay? Now what we call that is we call that a vertical stretch. I want you to think of pulling on this way. Vertical is this way. So if you can imagine taking this graph in red and stretching it, we call that a vertical stretch. If you go this way, we can also call this a horizontal shrink. You said narrow, and you're right. If we're doing a vertical translation, you want to say, okay, it's a vertical stretch by a factor of 2. Okay, so you want to write that down. This is going to write down that it's a vertical stretch, because one of the things you got to do is you got to name your transformation. So you should say vertical stretch by 2, factor of 2. That's how you do that, okay? The domain on this is all real numbers. The range on this is 0 to infinity, okay? So let's do this one more of these to kind of get you the idea of how this stuff works, okay? All right, the next one is an absolute value. So what we want to do with this one is the elementary function is absolute value of x. So you just do the absolute value of those numbers like we've been doing. So you want to do that. Then you want to plot these points. Okay, and that'll kind of go like that. That's your elementary function going like that. Okay, Now, the half. What's going to happen with this half, it's not a bad idea to write this down. You just take 1/2 times all of the y values. Okay, so it's going to do the same thing the last problem did, but it's got that, the fact that that's a fraction is going to have a different effect. So what you're doing is just doing half of the number. Half of 2 is 1. Half of 1 is a half. Half of 0 is still 0. That would be a half, and that would be 1. I'm multiplying all those numbers by a half. Okay. Now, if you plot these points, you would have the point -2, 1. So on your graph, you go -2, 1. You would have -1, a half. So just kind of estimate where a half is. You'd have 0, 0, and so forth. Okay, so your graph is going to kind of look like that. So that's the graph of y equals 1/2 absolute value of x, like that. Okay, what happened this time? Okay, and the vertical thing, it did what? It went this way. It's kind of like smashing it. So we're going to call that a vertical shrink. So you want to write down on this, we call this a vertical shrink, or sometimes textbook will use compression. Compression or shrink's the same thing. Okay, so vertical shrink by a factor of 1/2. That's what that would be. Okay, and then the domain on that's going to be all real numbers, and then the range on that's going to be 0, infinity. So let me kind of summarize something here, and we'll work on this a little bit more next week. So if you had something like y equals, let's say you had x to the third. Okay, if I put 3 there, what happens to this thing? It stretches, okay? How come? Because the y values get tripled. If y values get bigger, it causes it to stretch, right? Okay, what if I did this instead? Y equals 1/3 x to the third. If you multiply a number by a third, it gets smaller, right? So what does that do? Shrinks it. So you need to understand these things and how the math goes. Then you'll remember it like 10 times better. So what I have up here is if this number is bigger than 1, that stretches it because the y's get bigger. If that number is a fraction between 0 and 1, then it compresses or shrinks. That's what you got to think about. Okay, does that make sense? Okay, well, look on Canvas. One thing I want you guys to be sure to do, because I've got all the grades in except the exam, so it is a good idea.